Okay, so hi there everyone. We're going to continue with our videos in GE10. That's your college algebra. So we're here in our module 8 and we're going to talk about linear functions and equations here. This is requested by your instructor in the said subject. We're going to talk about first and define this. A function is said to be the central idea in the study of mathematics. In many situations, there is a mathematical function in which one quantity corresponds to another quantity according to some definite rule. So let us give a correct definition of the word function. So we have studied previously that the one relation was defined as a correspondence between two variables. So remember, we have one-to-one, many-to-one, and one-to-many correspondence of x and y, wherein we have this a set of ordered pairs written in this column form, x and y, where x is related to y. So in the previous definition, set x is called all the values of x and x are called the domain of the function. So remember, all the of x, all x's in the set x is what we call the domain of the function. So all x and x are is what we call the domain of the function, and we call all y's, all small y's, found in this big Y are what we call the range of the function. So a function is a special type of relation such that no two ordered pairs of the set have the second coordinates corresponding to the same first coordinate. So the set of all first coordinates of the ordered pairs is the domain of the function, and the set of the second coordinates are what we call the range of the function, same as what we call domain and range in relations. So in symbols, we call it y equals f of x. So instead of writing it as y in function notation, we write it and we equate that our variable y is going to be equal to our f of x. That is, it is a function in terms our variable x. Okay, so y is a function of x, where we call y as our dependent variable and x is our independent variable. So we also say that y is expressed explicitly in terms of x. An implicit function is not expressed in terms of a single variable, that is f of x equals 0. Okay, so we want to put this, for example, here, 2x plus 3y equals 6 is an implicit function, and an explicit function is in the form wherein y is on only one side of this side equation. This is implicit, wherein there's a combination of 2x and 3y here. And in other terms, you cannot see a y which is isolated on one side of the equation. When you say explicit, so it is isolated on one side, wherein we can see it here. So another example about implicit and explicit functions, for example, we write implicit as this. Implicit functions. For example, let's take uh we have, let's say, x plus y equals 2. So that's one example of an implicit function. Another example is, say we have 3x minus y equals 7. So what we're going to do in this example is we're going to convert them into explicit function for you to clearly see the difference between them. So explicit. So what we're gonna do for you to see it clearly is that we're going to convert this x plus y equals 2 into an explicit function. So by algebraic manipulation, we can transpose the x to the other side. We're gonna transpose it to the other side over here. And what we had as our first example of explicit function is this. So we have y, which we can equate this to f of x, is equal to 2 minus x. That's going to be our first example. And similarly, what this is what we're going to do in this equation here. We're going to equate first 3x on the other side, and then make sure that the y is positive. So we need to multiply the whole equation by -1 so that we can cancel the negative sign for the y. So what we have is y, which is again equal to your f of x, which is equal to -7 plus 3x. Again, we multiplied the whole equation by -1. So we can rewrite this as 3x minus 7. That's, commutativity. So we can write that if you want. Minus 7. And that's it for this video. For now, the first step that we have talked about is we have defined functions, and then we have seen some examples of implicit and explicit functions. So that's it for now. Thank you very much. I will be seeing you in the next video. Thank you.